So what we're going to do is we're going to look at those exponential functions first, just as a refresher, so you have something to compare to, because these are going to look different now. So when we did the graphing of exponential functions, it looked like what you're seeing on my screen here. The asymptote, right, was always the y equals 0. It was always the x-axis was our asymptote for this type of exponential function setup. Okay, so here's one graph example. It didn't always have to open up, right? Sometimes it was on its way down. Then it was an exponential decay. This would be exponential growth, okay? What we're going to do today is we're going to graph the inverses. We're going to graph the logs of these. So basically, same as before, when we graphed inverses, remember it reflected over the line y equals 0. Y equals x. This line right here, right? If you take a look at these graphs, that's what's going on. We just took the exponential and we reflected it over that diagonal line, okay? So how this works is now your asymptote is always going to be the vertical. It's going to be your y-axis instead, or the line x equals 0, okay? And then it can be going like this, or it can be going like this. It can go either way, but it's going to be using that vertical asymptote instead of the horizontal, okay? Okay, so with that, let's take a look at how this works. Still not using a calculator for this, okay? You guys can do these in your head. It's good practice, and you'll get what you need rather than some funky decimal this way. Okay, so when we graph a logarithmic function, like we said, it's an inverse, okay? So now, instead of plugging numbers in for our x values, we're going to plug those numbers in for our y values. You can see it on the screen there, 0, 1, 2, -1, -2. The reason being, when we turn this into exponential form, what does it look like? What is that in exponential form? What's the question you ask yourself? 3, but now our what power is what? How about if I wrote it this way? Maybe that will make a little more sense of it. Right? That's the same equation as this. So we would say 3 to what power? The y power, right? It's this to this power equals that, right? It's 3 to the y power equals x. So that's the exponential form of that logarithmic form, right? We just rearranged it. So that's the first thing you're going to do, is you're going to rewrite your log in exponential form. Okay, then once we've done that, then you're going to make a t-chart. But this is hugely important, you guys. You have to pick numbers for y. Okay, so you're going to take a t-chart and you're going to plug in 0, 1, 2, -1, -2 for your y. Why? Why do I want to plug them in for y right now? Is this easy to solve? It's not great, right? I mean, that one is. But the rest of them, not easy to solve, okay? So the reason we plug it in for y is 3 to any power is pretty easy to solve, right? We're just saying 3 to the first power, 3 to the second power, 3 to the 0 power. You work through all the numbers, right? So don't do this. So we're going to say, I'm just going to do it up here off to the side. We're going to say 3 to the 0 power equals my x value. What is 3 to the 0? 1. So my x is going to be 1. Then we're going to do 3 to the first power, and we get what? 3. Okay, then we're going to do 3 to the second power, and we get 9. Okay, now here's where some tend to have a little more trouble. Don't forget what a negative exponent does, okay? 3 to the negative first power is what? 1/3. It's 1 over 3 to the first power, and 1 over 3 to the first power is just 1/3. Okay, then we take 3 to the negative second, and we get 1 over 3 to the second, so 1/9. Okay, and again, when you're graphing these, if it goes way off the graph, count by something different. If it's just one that goes way off the graph, I don't care. But if it's multiple numbers that go way off the graph, just count by something else, okay? This one is not too far off. All right, so we know our asymptote is where? Always vertical on these, right? It's always that line. So I would draw that in right away when you know it's going to have that, because then if you cross that, you know you did something wrong, right? So vertical asymptote. Now plot these points. 1, 0, 3, 1, 9, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2 is right about there. And then 1/3, -1 is right about there. And 1/9, -2 is going to be real close to the line. And then you draw that line in. So our graph, oh, turned it into a shape. So sorry. Oh, that's terrible. Looks something like that. Okay, questions on that? So draw the asymptote in every time. Okay, that's the pink vertical line, the dotted line. And then you'll have that curve that never touches that line. I'm just plotting these points, right? So the point 1, 0, that's right here, 1, 0. The point 3, 1. So we go 3 to the right, 1, 2, 3, up 1. That's this point right here. The point 9, 2 is right here, so 9 to the right, 2 up, right? The point 1/3, 1. 1/3 -1. So you're going 1/3 to the right and down 1. That's this point right here, right? The point 1/9, -2 is like 1/9 is such a sliver over, but then down 2. So that's this point right here. X first, yeah. Yeah, left and right first, that'll be your X value, and then up and down is going to be the Y value. Okay? Okay, example 4. Last one of these, and then we're going to move on. So you are graphing y equals log base 1/2 of x. So rearrange that. How do you write that in exponential form? What? Oh, I thought you were talking to me.
Y to the 1/2 power equals x.
Not quite.
1/2 to the y power equals x.
Right, 1/2 to the y power, right? So it's your base, what it's equal to is always your power, equals x, okay? So 1/2 to the y power equals x. Now this is a little trickier, right? Because now you're taking 1/2 to a power. It's not terribly trickier, but it just is a little more to think about. What numbers are we plugging in and for what variable? For the y, right? We're plugging in for y right now. So I'm going to plug in 0, 1, 2, -1, and -2. All right, so let's do this. I would first start by graphing my asymptote. Looks like that. And now I'm going to take 1/2 to the 0 power. What is 1/2 to the 0 power? Anything to the 0 is 1, right? So that's a 1. Then I take 1/2 to the first power, and I get what? 1/2. Okay. Then I take 1/2 to the second power. What's 1/2 to the second power? Square both parts, right? What do you get? 1/4. Okay. Now I do 1/2 to the negative first power. Now, when I take a fraction to a negative power, what happens to that fraction? Flip it over, right? So 1/2 to the negative first power is 2 over 1 to the positive first power. So it's 2 to the first power, which is 2, okay? Whoops. Then it's 1/2 to the negative second power, okay? Flip it and make it positive. 2 over 1 to the positive second power is what? 4, okay? So those are all your points, and now we're going to graph them. I'm going to move this over so we can zoom in a little more. All right, so to graph this, we get 1, 0. That's right here. 1/2, and then up 1 is right there. 1/4 and up 2 is going to be a little closer yet to the asymptote. 2, -1 is right here, and 4, -2 is right there. So your graph looks something like that. Okay. Now it's going to be vertical. Yep. Whenever you're graphing a log or that like exponential form, that's you're going to have a vertical.
And we're always plugging in for a y.
And you plug in for y. Yep. Questions on that? Okay. Last thing, and I would say this is very easy because I will give you these formulas. So really it's, can you plug a value into a formula? It's not terrible. And I'll show you on the calculator in just a second how this looks also. So go ahead and get your calculator out if you don't have it, because you're going to get introduced to a new button. Okay, you have maybe in the past worked with pH. Have you ever done pH stuff in a science class yet? If you haven't, you will. But there is, with pH, there's acidity to things and there's base to things. And we're just going to kind of talk about that scale and where things fall and how you calculate them so that when you get to this in science class, you're like, I got this, Mr. T, no big deal. Or whoever, doesn't have to be Mr. T. So here's the scale, okay? If something has a pH of 0, it is acidic. If something has a pH of 14, it is very basic. So there's acids, there's bases. Anywhere in that middle region at 7 or 6 or 8, right in there, it's more neutral. So not necessarily acidic or basic, just neutral. So there's two formulas that we're going to talk about. The first is the pH formula, how you find it if we know what's called the concentration of hydrogen ions. So the pH formula is this. You take a negative log of the concentration of hydrogen ions. So this right here, that number will be given to you, and then you will literally plug it into your calculator to find the pH of some substance, okay? So just know that's what this is. H to the plus setup is the concentration of hydrogen ions. Okay, so let's figure this out. Example 5, it says lemon juice has a concentration of hydrogen ions, H+, of 5.0 times 10 to the negative third power. Find the pH. Anyone think they can do that right now? Look at your calculator. See if you can figure it out with me telling you anything, without me telling you anything. First of all, lemon juice, acidic or basic, you think? Acidic, yes. Did you get it?
Tell you the answer?
Yeah, tell me what you got.
I got 2.3.
Good job. Anybody else get 2.3? Did you find it? Good. Okay, here it is. I'm going to throw my calculator up here so you can see where I'm going with all this. Probably should have written it down here first. That's okay. So you're taking a negative, right? So here's your negative button. Where's log? It's right above your e to the x. Do you see it right here? Okay. Oh, I'm not in the right spot. Hold on. I don't want to be in a graph. Negative and then log. Okay, and then it starts that parenthesis for you, and that's where you're going to plug in your concentration of hydrogen ions. So 5.0, is 5 any different than 5.0 when you plug it into a calculator? It's not. So you can really just plug in 5, but if it makes you feel better to put in the 5.0, go for it. Times 10, and then caret to the negative third. You don't have to finish off your parenthesis because it assumes it right now, but if it makes you feel better, you may put it in. Just arrow over if you're going to do that. Hit enter. You should get that number, 2.3. Okay? So let me jump back to this, and I will write it in for you. Okay, so you're typing in negative log of 5.0 times 10 to the negative third, and you get a pH of 2.3. We would say that's acidic, right? That's more on the acidic side than the basic side. Okay. Questions on that? Okay. Buttermilk has a concentration of hydrogen ions of 2.5 times 10 to the negative fifth. What would you expect this to be? Acidic or basic?
Basic.
I would call this a base. Plug it in and tell me what you get. What'd you get? 4.6. Is that an acid or a base? It's acidic. Isn't that crazy? Buttermilk? Really? That's going to be here, right? That's closer to the acid. So 4.6, that would be acidic. Questions on how you do that? Is everyone getting those answers when you're plugging them in? That's very easy, right? Just drop it in. Just put it in your calculator. Let your calculator do the work for you. Okay. If we know the pH of something and we want to know what the concentration of hydrogen ions is in that substance, there's a formula for that too. And again, you're literally just plugging it in. Easiest thing you've ever done in a math class, right? Drop it in the calculator. So here it is. The formula for this one, if we're trying to find the concentration of hydrogen ions, it's 10 to the negative whatever your pH number is. Don't forget that negative, okay? 10 to the negative pH. So see if you can figure out what the concentration of hydrogen ions is for baking soda. This one might be a little more confusing because of the way it shows up on your calculator, but I'll explain to you what that means. Anyone think they know it? Did you get something like this in your calculator? Yes? Yeah?
Would it be 2 times 10 to the negative 9th power?
Yes. We usually round to the nearest 10th when doing scientific notation. This is scientific notation, okay? When you get this, what they're saying is this is basically times 10 to the negative 9th power. E negative 9, that's times 10 to the negative 9th power. We want to round this to the nearest 10th. So nearest 10th, this would be 2 point what? Zero, okay? And the zero matters. I know people think it doesn't, but it does, because 2.0 or 2.1 or 2.2 or 2.3, those could all be rounded to 2 if I'm talking whole number, right? We're not talking whole number. We're talking nearest 10th. So 2.0 is a lot different than 2.4, okay? So just make sure you're giving a tenths place. So your answer is 2.0 times 10 to to the negative 9th power. Is anyone not getting this when you plug it into your calculator? No? Okay, so you're going to take your calculator, you're going to go 10, and then the little caret, right, to the negative 8.7. Is that what you plugged in?
No.
Okay, try that real quick. So 10 to the negative 8.7. Are you still what? Plugging the negative in? This. No log. No, it's just 10 to the negative pH. Yeah.
How come we're not plugging in the log?
The formula to find this doesn't include a log, right? So the other formula has the log. It's a negative log of the concentration of hydrogen ions. This formula is just 10 to the negative pH to find the concentration of hydrogen ions. So you don't need log on this one because that doesn't require it for this formula. Any questions on that? Not terrible, right? Not terrible. So just take your time when you're graphing. Don't use your calculator. Don't plug it in. I want to see that you can take something to a negative power, flip it over, right? And then these ones should go really quickly for you.